Hello, my name is Jonathan Hollifield, Executive Director of the White House Initiative on HBCU. Welcome to the Contracting Competitiveness track of the 2020 Virtual National HBCU Week Conference. We think you're in for a treat. This track represents some of our best efforts to push out new opportunities toward HBCU. We also encourage you to connect up to those opportunities, which ultimately can result in a pull down of greater value to serve students and communities. We're excited about this year's offerings and hope you will be as well. Let's continue to compete hard for top federal opportunities.
Welcome to the 2020 National HBCU Week and Conference. To start off the Contracting Cluster Workshop Track Session 2, please welcome theoretical physicist, U.S. Department of Energy, Dmitry Kuznetsov.
Hi, good afternoon. Welcome to the session on high performance computing and artificial intelligence and how HBCUs might accelerate their competitiveness. I'm Dmitry Kuznetsov. We're really delighted to have this session today. I'm happy to moderate it and provide my personal technical opinions on HPC and AI. We have a remarkable panel online for you today. But before we get going, a quick reminder on how to best interact with us. For all of you listening in, I'd encourage you to submit your questions via the Whova app, its Q&A feature. So to do that, log into the Whova app, go to Agenda, select the HPC workshop. The Q&A feature will populate alongside the chat and like button. Submit your questions to the Q&A feature, but not to the chat button. We'll try and answer your questions by the end of the workshop if time permits, but more than likely we'll have to post the answers to the Q&A by Friday, October 2nd. So we're going to focus on the high impact of HPC and unleashing of AI and how those worlds are coming together and the role HBCUs can have. It's a tall order for just one conversation, but I hope at least we can get this started and think about deeper discussions that will follow. The remarkable panel today is drawing the best from industry, universities, and our national laboratories, and they're going to share their perspectives on HPC and AI and where these industries of the future are going. So what is high performance computing, and why should we care? We throw the word around a lot, but at any moment in time, high performance computing reflects the largest, most complex combinations of existing technologies that we can cobble together to solve our hardest problems. We look to see what's available, we put them together in the biggest way so that it operates as a single unit, and we say, is this enough to answer the nation's pressing questions? HPC is not a means to an end. It's only a tool, and it's a tool to solve problems that can't be solved any other way. But tools have to have a purpose or they go unused. So it really starts with defining the problems you don't know how to solve that might be solvable potentially through computing, or at least better understood to guide decisions with the use of high performance computing. Today we have more challenges than solutions, and whether you worry about food deserts around HBCUs or nutrition, or water, or energy, the economy, cybersecurity, or even artificial intelligence, certainly pick your problem. HPC may provide a means to better understand options and consequences to decisions we could make, and to make progress against these things, the kinds of problems that keep us awake at night. Today, and I think Patricia and Becky may speak to this in a moment, we're building the world's fastest supercomputing systems here in the US with the potential to do 10 to the 18 calculations per second. 10 to the 18 is a staggering number. It's one with 18 zeros. I think it's hard to get our heads around what that really means. You can say it in many different ways, but it never quite works. If you did an addition or subtraction every second, it would take you 32 billion years to do that many calculations, which is, more than twice the age of the universe. And so when we build these big systems, what they can accomplish is staggering. And I think we're limited by our ingenuity and how innovative we are on new ways to potentially use this to answer some of these really hard questions that bother us. HPC systems are big, they're expensive, they take a small army of people, many different skill sets to use them effectively. William's going to talk about some of these skills and how you cultivate this ecosystem. Being involved with HPC is much more than learning computing programming. The types of skills that are needed in the HPC and AI ecosystem to keep it vibrant is on every one of our panelists' minds today, and I think they're going to touch on that, and I hope it resonates with where some of the schools are trying to go. HPC is also a key enabler for the leading edge of artificial intelligence today. Learning from data, what we call deep learning, is extremely computer intensive. And we use high performance computing to push the boundaries of our understanding in artificial intelligence and understand how intelligent the next generation of AI systems are really going to be. We can open the door a crack by pushing the frontiers of computing on some of the largest data sets we have. So using HPC opens the door not only for simulation, but also for AI, and it's a way of getting ahead of the next wave of the industries of the future that are going to be built on AI. On the AI front, it's data and HPC intensive effort that's impacting virtually every economic sector today. You know, if you look at how people estimate the economic value of innovation in AI, it's measured today in trillions, sometimes tens of trillions of dollars. It's going to impact everything. There's going to be local, regional, and national economic impact for those that push forward, and it's precisely now that we should be trying to organize ourselves to define this future. HBCUs represent a deep talent pool that we need to better align with these possible futures, and I hope to get this conversation started here a little bit today with our panelists today. You know, what's interesting about AI in contrast to HPC is we don't actually know what AI is today. It's in its infancy, and it's really anything you want it to be. If you tell me that this is what you consider to be AI, my answer will probably be sure, why not? You know, people use 50-year-old tools together with the latest data and ideas to solve problems in new ways. And it's how you cobble together different sets of things to solve things that are important to people that are becoming part of this suite of tools we call AI. So whatever you call it today is fine. I think time will tell what's useful and what is not useful. And so AI is not a technology or a thing. It's really a way we try and understand both old and new problems in new ways using today's available technologies, available data, and methods framed years ago. You know, here the skills needed are still formative. We need generalists. AI intersects ethics and privacy and trust. And efforts are going to be far more general than how we've traditionally approached computing. It's more than just an engineer or a computer programmer or a computer architect. And I think we don't actually know what the skills are going to be. But I think looking at HBCUs that have very broad liberal arts backgrounds as well, you know, there is the opportunity to try and take a more formative approach to how these broader educations can impact the future of AI. Anyway, you know, we should get started with our panel. Just to say a couple of words, so again, of my esteemed colleagues here today, we have Patricia Damkroger, who's Vice President and General Manager of Intel's Extreme Computing and Data Platform Group, among other things. And Intel is, by the way, currently, you know, a leader in driving the next generation, the frontier of high-performance computing. Becky Springmeyer is at our Department of Energy's Lawrence Livermore National Laboratory. She is the Livermore Computing Division Leader. It's a lab where high-performance computing and AI are really in the lifeblood of everything they do, a lab we turn to solve many of the nation's most pressing problems. Chuck Howell is Chief Scientist for Dependable Artificial Intelligence at the MITRE Corporation. He has a broad view to artificial intelligence, where the technologies are going in this complex, ever-evolving landscape that's moving perhaps 5 times faster than Moore's Law. And keeping your fingers on the pulse of that is already a tremendous accomplishment, and we're going to hear from him on what that looks like. And William Burke is Senior High-Performance Computing Engineer at the George Washington University, really represents the academic seeds and the excellence we need to our success as a nation. I'm going to ask each of the speakers to add a few more remarks that are relevant for this conversation. And again, more of their bios are available on the Whova app. And so maybe let's start with Patricia and thinking about high-performance computing. You know, where's it going? What's the view from industry as a leader in the field?
Great, thanks, Dimitri. So high-performance computing has obviously been around for a while, but let's talk about kind of where we are and where we're going. You mentioned exascale, and exascale is that next frontier that we're going to be tackling in the next couple of years. We'll start seeing some exascale. We're currently in the hundreds of POPs if you look at the fastest computers in the world. And exascale is just a challenge technology-wise as far as what it's going to take to get there, the power needs, the programming requirements. And so there's a lot of hurdles to get to a good, capable exascale machine. And we're all working as an ecosystem and industry together to get to that. The other kind of, maybe not the other extreme, but close to it, is HPC in the cloud. So HPC in the cloud is growing. It's we've been talking about HPC in the cloud for probably a decade, and I would say it is now currently happening. If you look at the top tier CSPs, so cloud service providers such as Microsoft, Amazon, Google, they are all bringing up HPC specific instances. And so they're looking at those performant cores. They either are using a high bandwidth fabric that's available or developing their own. They're looking at bringing in those large companies and small and medium companies to make it easy to use HBC. And I'm excited about it because it really is the part of democratization of HBC. I want to see more and more people have the ability to use HBC. And as like Dimitri stated, in the past that's required a staffing of people and a lot of space when you had to bring it on-prem. So with HBC in the cloud, if we can make it more usable, we can really start reaching those small and medium businesses. And that's where we're seeing a lot of growth in the cloud. The other trend, as Dimitri talked about, is AI. So when I think about high performance computing, I think of traditional modeling and simulation, but I also think of high performance data analytics and also artificial intelligence. Because it's not just the infrastructure that HPC has traditionally been run on is required for those two other elements, AI and high performance data analytics that we've talked about, but it's also that we're starting to bring in AI-based models or data-based models into our simulations. So I think those are two elements that we're seeing, and it's kind of exciting to see being able to take advantage of AI and even speed up what you can do with high performance computing. I mean, another element that Dimitri hit on is high performance computing takes time. I mean, you can run these simulations for hours to weeks and even months, and the need to, that's why exascale is important so that you can do more, but also just being able to speed up what you can do within modeling and simulation, such as converging with AI, is going to have a tremendous benefit for our HPC ecosystem. So those are the trends I see.
You mentioned HPC in the cloud. How straightforward is it if you're trying to enter HPC to start to engage a cloud provider? Do you have to have everything ready? Are there ways to step into it and try and learn what the tools are and pace yourself into it? How big a hurdle is it? It sounds kind of scary from the outside. How do I do that? But what's really involved if I wanted to do that, but I wasn't too familiar with HPC or programming at that scale?
Right. No, great question. I think there's different levels that you can engage, whether it's going to bare metal, which you would traditionally do on-prem, and the cloud service providers are offering bare metal, but there's also the opportunity to use through the ISVs, so whether it's an ANSYS or an Altair, to do and just use their tool set so that you can go on and you really don't have to then set up an HPC infrastructure. So there's different opportunities or different levels of how you can engage and how far you can get into the stack. But I think small, medium businesses are definitely being driven more towards following those ISVs or independent software vendors to take advantage of parallel computing that's beyond their workstation, but also not have to understand how to really run an HPC workload.
William, I was wondering if I could put you on the spot for the same kind of question from the academic point of view. If you wanted to, step into HPC, from your perspective, how easy is it to work in the cloud?
It's relatively, there are some challenges. However, there are a lot of tools and programs that are in place for the major cloud providers such as the Amazon or Azure. We have, as a school, has been able to utilize both types of cloud, and there are some workloads that are perfect for the cloud, and then there are those that may not necessarily fit well within the cloud. But you can certainly provide that collaborative and committed work that needs to be done on the cloud in terms of projects that may stem, like for instance, we have many different types of workloads, from physics to biosciences and such, and some of those types of workloads are perfect for the cloud. The ones that are sort of comparatively parallel really fit well within the cloud.
In thinking about computing and how it has an impact, I'm wondering whether we could turn a little bit to Becky. Livermore has been, at the frontier, pushing some of the world's largest simulations, really using and defining the scale of high-performance computing. Where does it have a real impact, Becky? As you think about the technologies that are out there and available, can you do it anywhere? Is the cloud a good place for you too? What kinds of things can you do? Where does it make a difference? Where can you do things that you couldn't do any other way? Kind of broad brush. What do you think?
First, I'll introduce myself as being from Lawrence Livermore National Laboratory and the division leader for Livermore Computing. That's our high performance computing center. And I'm also the director of our lab's high performance computing institutional computer center that runs grand challenge projects from scientists across the whole spectrum of science and engineering applications at our lab. So I partner with those scientists to gather requirements and steer our computer architectures and software decisions to best serve the lab's scientific missions. And those actually range from cloud computing sorts of applications to ones that can only be done on the largest supercomputing platforms that we have in the world today. So first, I'd just like to say overall, how does HPC have an impact? We have an impact in the real world, in medicine, biology and environment, seismic science, which is especially important to us here in California, climate modeling, and national security issues like infrastructure protection or explosives detection, and emergency response support. So the national labs bring together large multidisciplinary teams of scientists and computer scientists, engineers, mathematicians, and others to solve problems that could not otherwise be solved at this level. So with the extreme scale of supercomputing, we can run problems in an hour today that would have taken days or even much longer in the past. So when new threats come into the world, such as COVID-19 and the pandemic that we're all suffering from now, the national labs come together to fight the threat. So in our lab, that meant immediately granting expedited supercomputer time to our own computational biologists, and we joined an HPC consortium Partnership is extremely important to high performance computing, and Intel, along with other vendors, joined together in this consortium with national labs and vendors. And at our lab, we brought in more than $8.5 million of new machines with specialized hardware in order to best support those whose calculations are searching for how to defeat this virus. So those partnerships are key, and the different kinds of computing are key. Cloud computing is one tool. Another is high memory for applications that need a lot of memory. Others might be, things that use GPUs. And now on the edge of what will come next after exascale, we're looking at all sorts of technologies. So it's a really exciting field where you bring together the latest in hardware advances with software that can harness that hardware to solve some of the most important and pressing problems at the most extreme scales.
Yeah, you mentioned a couple of things here I want to follow up on. You have, from seismic issues, things that impact you locally there, perhaps in California, climate issues, emergency response, biology, medicine. You create a lot of tools that are usable on these big systems. To what extent are these tools open source in that HBCUs, for example, could link up with you and say, hey, I'd like to exercise this tool also to solve this kind of problem. It might be suitable. Do you share your software tools in some way? And if so, how do you follow up on that?
Absolutely. So we're big on open source, and we have been ever since the first compilers that we wrote at Lawrence Livermore 50 years ago. So if you look up LLNL and open source, you find that we have a large catalog with literally hundreds of things in there. For high performance computing in particular, we have a lot of tools that help you run the supercomputers, monitoring and so on. But we also have a lot of application software. So for example, the scientific seismic software, some of that I believe is open source. And also just for HPC itself, we have a lot of infrastructure software. So for example, how you build large packages on supercomputers, it can take people literally weeks because there are so many interdependencies with compilers and other things. So we have an infrastructure team doing something called SPAC. So if you look up SPAC, S-P-A-C-K, you can see that we have mathematical ways of understanding these dependencies and boiling it down to an automated process so that you can literally get this done in hours, what would take days before. So another one might be debugging at scale. We release all of this software so that other people can not only use it, but contribute to it. So for the SPAC software, there are people all over the world who are now developing. If you go into GitLab and you look around for open source software, there are many things from our lab that you can contribute to and many other labs as well. It's really a wonderful way for computer scientists to come together and work on each other's software in ways that make us all as a team much stronger than if only one institution was working on the software.
Yeah, thanks. So GitLab is something that one can just find and download tools from and play around with.
Sure, yes, you can go on there and search around. We have ours organized as a lab. If you look up LLNL and open source, you'll see a catalog of all sorts of open source software that you can download and look at. A lot of them with read the docs or other things that will explain to you what the software is and does and how you could get involved. And then for people who want to contribute, you can put your ideas out there and do pull requests, and someone who's in charge of the software will look at that and see if they can accept it and send it upstream so that everyone can benefit from the software.
I think an interesting thing about the HPC ecosystem is that the technologies interact with the problems in strong ways. And I think you and Patricia represent kind of both sides of that in something that the department has been doing for many years, something called co-design. That the problem shapes the technology, and in turn, the technology shapes how you solve the problems. And I was wondering whether you could talk a little bit about that from Intel's point of view on for example, how you think about your next generation of tools, of offerings, of designs in the context of the problems you're trying to solve for HPC. And from the lab's point of view, how you in turn think about, well, how do you work with that technology and how do you tweak it to solve your problem? It'd be nice to hear kind of both faces of that, because I think that interaction is a unique dynamic in HPC that has been vital for its success, and it touches so many different skill sets. I don't know, Patricia.
Sure, I'll start. I think, I've worked on both sides. So I actually came from Lawrence Livermore National Labs before I joined Intel about 3.5 years ago. And I do agree with you. What I find unique about high performance computing, when I compare it to a lot of the other businesses that Intel's in, is this close interaction that we have with our customers. So it's not even, we're looking longer term. So right now we're working with customers on something that's 3 to 5 years out. And we haven't thought about the silicon in order to do that. But what are those instruction sets and features that they're going to be needing as they look at what their applications and the problems they want to solve? And it's true design effort. We talk about what is needed as far as, should we get more integrated? Should you get more discrete? What are the advantages and disadvantages? What is the software environment that you need? We have just announced last year one API, again, an open standard framework for people to use so that you can be hardware agnostic, because that's becoming more and more of the problem about discrete versus integrated. So I agree with Intel. It's something that it makes it a unique business inside Intel, and it's something that my cloud service provider part of the business that I work with are quite envious, and they're trying to model our work to work closer with the cloud service providers for the future.
Becky, what's your view on co-design?
Yeah, I'd like to talk a little bit about co-design on the software side. So for example, right now we're working on our next generation resource manager, which means how do you split up the time on the massive supercomputer so that many people can use it at once? And in the past, we just did this with Slurm, a tool that would let us schedule nodes. But now we need to schedule things like GPUs and worry about power management and other things like this. And we're managing workflows on these supercomputers that bring in databases and all sorts of complicated moving parts that we didn't have as much in the past. And so we need to manage the workflows. And so one thing we're doing is doing co-design of Flux with other tools, like, for example, Kubernetes. Open source software that underscores this, making sure that things that scientists run on their desktop can also work on supercomputers is important. And so co-designing these tools so that we can move from platform to platform and be portable is a very large problem, and one that we're glad to work on with many vendors and open source vendors, if you will, as well.
Yeah, well, thanks about bringing up graphical processing units, the GPUs. They're an important piece of how we do AI today at many different scales, and maybe it's a good place to kind of turn to Chuck and think about that. The HPC systems we have today are very heterogeneous. That is, it's not just the standard computer chips, the CPUs. They have many GPUs, thousands of those as well. And so they can look like large AI systems. And it's opened the door to do many things in AI that we really hadn't thought about before. And so thinking about this, what is the intersection of HPC, high performance computing, with AI today? And kind of give us your broad view of how these opportunities are emerging today and how we should get our head around all of this.
Sure, I'd be happy to try. Let me just give a little context to introduce MITRE. MITRE is a .org. We're a not-for-profit corporation, and we manage 7 of what are obscurely called federally funded research and development centers, which means that we are organized to provide systems and scientific systems engineering and scientific support to various government agencies. But the reason that's relevant is across those 7 federally funded research and development centers that we manage, we have a broad range of government organizations that we support, everything from the Department of Defense, IRS, Veterans Administration, FAA, and various healthcare organizations. And the reason that's valuable is it lets us extract lessons learned or see opportunities in one area, and then see how they line up with or how they can be extended or adapted to another, and see where there are common trends. And so I'll try to extract from all of that just a couple of trends to respond to Dimitri's point. I just want to echo that the machine learning is the subset of artificial intelligence that has just really been the rocket engine for the growing both capabilities and also interest in investment. I've heard for years machine learning described only slightly tongue-in-cheek as high-performance linear algebra. The matrix manipulations that underlie a lot of supervised deep learning in particular really lend themselves to that architecture of those approaches. And they are both insatiably data hungry and insatiably compute hungry. And so I think Dimitri put it well that high-performance computing allows us to sort of put the high beams on and look a little further down the road in terms of what will become possible in widely deployed capabilities very soon. And it also is just the case that what we consider sort of standard capabilities now would have been extraordinarily high performance computing not that long ago. So they're related in that way. The thread, I think, that's interesting across all of the different organizations that we support is that just to start with my firm grasp of the obvious, AI and in general, machine learning in particular, is rapidly moving out of the proof of concept stage and finding cats in internet videos, et cetera. And it is being used and being prepared to be used in increasingly consequential systems. And that presents both opportunities and challenges. And that means that it is inherently, the other thing that is just consistent across all the applications of AI that we're seeing at MITRE is that it's inherently multidisciplinary. And so you can't really make progress and you can't really take advantage of the opportunities and mitigate the risks that this technology presents unless you have a wide range of stakeholders and a wide range of disciplines involved from the start. And that creates an opportunity for some novel combinations of skills and backgrounds that's still being worked out. It's very much, the concrete has most definitely not hardened in terms of what are the different combinations of skills and the different kinds of disciplines that need to be brought to bear and how. So I think that's it's an open field, and I think that's a great opportunity for, as an example, for HBCUs to take advantage of that sort of gap and fill it with really novel, intriguing, and really important mixtures of disciplines and mixtures of different stakeholder perspectives. That will, first of all, close some of these gaps and help accelerate our country's ability to take advantage of the opportunities that AI represents. It also helps equip the talent pool, which is desperately needed. In fact, I support there's an organization called the National Security Commission for Artificial Intelligence that was chartered by Congress about 18 months ago. Eric Schmidt is the chair, and he, along with some of the other commissioners, was testifying before Congress last week. And they went through some of the recommendations of the panel. And he was asked, but if you had to pick just one, what would you say is the single most important recommendation from the commission? And without any hesitation, he said, talent, people. We are woefully short, and it's not getting better. And I would argue that's also both a huge opportunity. There's just an insatiable demand for that talent, but it also is not all the challenges and all the opportunities aren't just what runs on electricity. And so again, this notion of a multidisciplinary team that can really help us collectively take advantage of the opportunities and avoid the risks. The sky is the limit in terms of the opportunities. So training a workforce to respond to that demand, I think, is a great benefit of pursuing some of these opportunities and gaps.
Yeah, that
One of-
commission's reports, I think, are available online. Their interim reports, they are good, as well as their other findings, such as AI ethics and so forth. So I'm glad you're supporting that. That's I think, a notable thing to look up.
Thank you. Yeah, it's a fascinating organization or fascinating activity. And speaking just for a second, you brought up ethics. That's actually the part of the commission that I support, the Responsible AI and Ethics line of effort. And again, an expression that's been used more than once is that machine learning is money laundering for bias. That there are just horrific examples already of unintended consequences of the use of machine learning to unintentionally incorporate all kinds of systemic bias or baked-in assumptions, and it can be a really difficult thing to detect that, and it can cause real harm and has caused real harm. And so the concerns about that could be a real barrier to adoption of AI if we can't establish justified confidence that these machine learning systems aren't going to be force multipliers for systemic bias and assumptions. And so again, one of the observations that's made repeatedly is the need for a diverse range of both stakeholders to represent different interests and different needs that may be affected by this system, and also a diverse range of developers from the start, so that different perspectives and assumptions are again baked in from the start to the development of these systems and their evaluation and their deployment. So again, I think there are huge opportunities and demand signals there, and it is early days in all of this, and so I think that it's an exciting time to shape it, and it's an exciting time to contribute to a desperately needed cohort of trained people.
Yeah, shaping it's important because, as you said, we actually don't know all the skills we're going to need, but what we do know is that they are not the traditional ones we have used for high performance computing, and we have to step back and think a little more broadly about how to do this. Another
Absolutely.
interesting point perhaps is HPC, the high end of computing, is opening the door on how to think about AI, but ultimately what we need are things at the small end. We're going to want smart medical devices. We're going to want things in our pocket, in our home, in our car. And so the high end is driving innovation, but the end point is going to be technologies customized to problems that we care about, where we live, and that impact our lives and the problems on our short list. Could you talk a little bit about that, especially in the context of perhaps 5G and the growing bandwidth we have for devices just to talk to each other? It's a new world that's emerging before our eyes, and getting our head around that is not easy.
No, I mean, I think you put it well. I think one of both the exciting opportunities and also the challenges is really understanding what the implications are of this. I mean, it took a while for the real implications of the internet to sort of sink in and be reflected in the way we do business and the way we live, et cetera. And I think the same certainly true for widespread use of very, very sophisticated machine learning, combining that with the Internet of Things, with 5G. So I think you put it well, that we don't really understand what all the implications are of those interactions. And I think it was Alan Kay who said the best way to predict the future is to build it. And so there is an opportunity to shape that. The one other point I'd make about these interactions is unfortunately, we already talked about sort of the unintended consequences. Things happen that no one deliberately intended for this outcome, but it happened, and it had disparate impact. For example, when you combine machine learning at the edge, lots and lots and lots of devices, the high capacity that 5G represents, you open up the opportunity for emergent behavior, for behavior that really only manifests itself at that system level, and it's not reducible to just individual components. And those are traditionally very hard to, by definition, I guess, very hard to anticipate and very hard to control. And I think that's a huge gap and a huge need to try and get a better feel for how to put in effect barriers around the behavior or the performance of these systems as we compose them, or at least guardrails, so that we have some confidence that no matter what happens, they'll behave in the following ways. This, I think, is particularly true in systems that are combined that are influencing human decision making. Recommender systems, decision support systems, whether it's clinical decision support or command and control or traffic management or emergency response, because there you really are interacting with a whole bunch of complex individual components, including humans and roles, and you are very likely to get emergent results. I think the other thing that's just, again, I'll end the way I started, showing my firm grasp of the obvious, but what we consider a very small embedded processor today would have been a pretty decent mini computer not all that long. I mean, the Raspberry Pi is a computer, and that's a clunky old dated example at this point. So I think, again, there's this notion of even high performance computing being sort of the high beams for what may be coming in terms of compute capability. And then I think earlier there was a discussion about the use of high performance computing for very high fidelity simulations. That's another way to sort of explore this complex mix of socio-technical systems and try to get ahead of it a little bit and see what might emerge before we actually deploy them. So I think there's a nice synergy there.
Yeah, in terms of the technologies and the pace of computation, I think Patricia could probably tell us how many billions of transistors Intel puts on a chip these days. It's just staggering what you do over there. With the socio-technical systems, I think that's an interesting statement. And I think maybe turning to William here to hear a little bit more about how the world of HPC and the skills you need now with kind of the rapid growth in AI is shaping the kinds of skill sets you need, but also with an eye on how we might think about building capacity at HBCUs, how we could interact together, given that not all possible technical courses are available everywhere. How do we think about the skill sets that are going to be needed for us to thrive and for economic sectors to grow?
Yeah, so just to give sort of a context, I'm the senior systems engineer at GW, the Research Technology Services, and we have a shared high-performance computing environment, and those are shared across the infrastructure. And there are a number of projects that we work on, and one being very relevant today is the COVID-19 research, and some of it is some of that computation actually happens to run on our HPC clusters. So in terms of the skills that are needed, I think we need to kind of think about having those intentional alliances between the forward-thinking folks within industry, such as whether it be Lawrence Livermore or Intel or any one of the large organizations, and to forge those lasting partnerships, because it's very necessary to pivot and the development of implementing innovative solutions that what's necessary for folks to be able to utilize is the the courses such as things like probability from an academic standpoint, statistics, the linear algebra, the logic. These are some of the things that are necessary. But also being able to sort of communicate those things, because within the skill sets that are needed, there's lots of engineering, as we were talking about AI, and a lot of the analytics that has to go on within that framework. But I think the biggest thing that the biggest thing that is necessary is for for preparation in sort of this field is the collaboration. Committed to creating these types of integrated undergraduate level or graduate level courses that reflect what the industry actually needs. And so in terms of, like, say, for instance, industry there, like Apple has an initiative to, for coding and creativity, and that sort of workforce development opportunities that, and especially if it's for the historically disadvantaged learners at HBCUs. And then there's the pipeline to sort of produce that future talent, because as we were sort of saying that, as Chuck was saying, there's a huge demand for AI, and in terms of HBC, we need to sort of have that diversification in place, and I think we can certainly work towards that sort of project-driven work in terms of setting up sponsorships, mentorships, and what we do some boot camps here and hackathons. I think those, sort of creating those sort of support systems will sort of build that and bring that to the forefront for providing the funding and building that pipeline for large number of people that need to be within that space.
What do you think of the classes that are the kinds of courses that you need or you're going to need, in part of what we just heard about AI and Chuck's comments, ethics and bias and trust and privacy and these kind of more social side of things that are not necessarily programming or technology specifically. How do you think about the kinds of professional skills that are going to be needed for these economies to come? And how do you prepare for that?
Good question. I think the things that are needed in preparation for this. So to answer your first question, what is needed besides just sort of the technical and mathematical skill sets? I would certainly say that due to the types of projects, project management, having the type of coursework where you're looking at things like, for instance, in our biosciences or our computational bio institute, having a bioethics, classes in terms of, where do you sort of draw the line in terms of what happens to that human data, or in having that compliance to storing that data. So I think that the types of things that need to be in place are ethics types of workloads, and then the community as a whole to sort of partner with industry, and to understand what are some of the what are some of those types of challenges. We were talking about artificial intelligence and some of the sometimes the biases that can be placed within those codes, but being able to broaden that with the existing, not existing, but with a student group that's inclusive of not only just men, but also women, and sort of growing that. So I think those are some of the things that we can do.
You mentioned the words intentional alliances. So I, thinking aloud again, GW of course has a fine law school. You have an engineering, computer department. You have a lot of interesting tools. Could you imagine partnerships? I think to make these fields successful, as Chuck said, it'll probably take non-traditional partnerships to be spawned to somehow align. Could you imagine intentional alliances with HBCUs that draw on the kinds of skills cultivated today at many of the schools that could then help with thinking through some of these problems and pushing the fields forward?
Yeah. So I think that in terms of the schools and having those intentional alliances, one of the things that we do is that we we have many institutions, not many, but I should say we have Exceed and NSFDOG, open science type of work, and internet too, as we form those types of partnerships in between schools as well as with industry. And so I think that, we can build things that sort of sharing that strategy and knowledge and building those types of networks so that we're able to have a more robust high performance research and education infrastructure. And those are some of the things that we do currently. I mean, we have our own network, which is called Capital Area Advanced Research and Educational Network, and we have outside organizations that actually utilize some of that in a high performance research capacity.
I'd like to also ask a similar question to Becky. The labs certainly hire a lot of people across many different skills. The talent pipeline coming from the universities is especially important to you. Partnerships, internships. What are the opportunities that the laboratories offer to help, jumpstart some of these discussions?
This is one of the favorite parts of my job, which is ensuring that we have strong partnerships and pipelines and so on. If you go to Lawrence Livermore National Lab to scholars.llnl.gov, you can see the range of summer programs. And if you go to any one of our national labs, you'll find that each one hosts summer students, sometimes co-ops throughout the year. And one of my favorite things to do is have someone join as an undergraduate, get involved with their professor, have a partnership with the university professor who has multiple students, fund them through contracts, and see them grow over the years. And some of them go into graduate school and specialize in something that's a partnership between industry and the labs, and bringing more money into the university, and also then becoming ultimately a researcher who goes to a national lab or back into a university. So we really have a community of people who can take different directions depend on their studies. So if there are some professors in the audience, looking for things not only for your students, but for yourself as collaborations, is one of the ways to get this started. Then once you have one student who does that, then you have a pipeline started. And so that's a favorite thing for me is the students, but also in general, the partnerships for solving new problems. So if we do a strategic initiative or research project, our researchers are looking externally to our lab for people who could contribute from universities. And so putting your name out there, being aware of the research that's going on, the research that's awarded, the contracts by the government, and trying to get involved by going to conferences, hearing what's going on, and striking up conversations with people. These are just a few thoughts that I have on how you might get involved.
So, since we only have a few minutes left, maybe I'd like to ask each of the panelists today, how schools could learn more, whether you're a student or faculty or part of the administration of one of the HBCUs. Where should we point some of those watching today on how to learn more, who they can contact if they want to take next steps? Maybe kind of run down in order of how we introduce speakers. Patricia, if you don't mind, if someone wants to hear more, I know you're a lead there at Intel. Where do we point people?
Well, again, we also have a very active intern program and hiring program. So at Intel, you can go and see all the opportunities there. But one thing that I did want to point out is we're having Dan Olds is putting together a Winter Classic Student Cluster Competition. And this is for historically Black colleges and universities and Hispanic institutions. And so this is a great opportunity to learn a little bit more about high performance computing and the skills, and we'll be working with you. So get in touch
Is there
with
a link
me
to that?
or yes,
Good.
it's dan.olds, OLLOLDS, at gabrielconsultinggroup.com. GABRIEL consultinggroup.com.
Okay. Good. Becky?
I'd also like to put in a plug for hackathons and cluster competitions and this sort of thing. We have a couple of young women who work for us now who started because we went out to University Pacific and started the first all-women team for supercomputing. So these sorts of things are good. And I think I already gave scholars llnl.gov, but if you go to careers.llnl.gov, you'll see all the sorts of opportunities that are there for hiring people in various different areas. It doesn't have to be just computer scientists. So those
Could
are
you also direct people to the other national labs? Is that something also possible if you had some of those, just to kind of
yes, I think
broaden
so.
that aperture?
One great thing for learning about high performance computing is the Argonne summer program about high performance computing. So if you just search for HPC and national labs, you'll come up with some of these. Also, I would say to go to the DOE, Department of Energy website, and they list all of the national labs. And then there's a link to each one of them there. They all specialize in something different. But a lot of the HPC labs include Oak Ridge and Argonne, NERSC over at Berkeley, who's our neighbor, Sandia, Los Alamos. For all of these labs, if you just go to DOE and look for the list of national labs, that's where you can have a link to each one.
Thanks. Chuck?
Well, the easiest URL to give is just if you go to mitre.org, it'll first of all provide an overview again about MITRE and the different organizations, and there's a bunch of material about the research products, et cetera. But to specifically answer your question, under the careers banner at the very top, there are two that are particularly relevant. One is it actually goes to mitre.org/careers/student-programs, cleverly named, and that gives an overview and a connection to link to both summer internships and also new grad opportunities, and describe some of the different roles and different opportunities. And then under the same banner, again, equally cleverly named, mitre.org/careers/academic-engagement. But you get to all of these just by scrolling across from the front page. And that describes the partnerships that we're always seeking to, and collaborations that we're always seeking to make with a wide range of universities. And it explicitly calls out beyond recruiting to research collaboration, that this is meant to be a collaboration. And there's clearly an appetite for a broad range of collaboration, right in line with the multidisciplinary approach that we talked about earlier.
William?
Yeah, I think the easiest thing for me is that you can go to gw.edu and type in Minority Serving Institutions Award, and that will give some information in terms of the funding assistance for graduates of minority serving institutions. And then there's the Karen.org, which is our research technology services website, and there you'll find there's 4 different sections: career specs, Karen specs, cybersecurity, smart cities, and definitely research. And feel free to reach out to me is on wburke, WBURKE @gwu.edu. And we have internships. Thanks.
Got about 15 seconds left. I'd like to say thank you to the panelists. I always learn things from this. Thank you again for sharing your time with us today. It is a remarkable time for many reasons, and perhaps one of the most transformative periods in decades. And I'm happy to share this with all of you, and thank you again today. Don't forget to use the Whova app to upload your questions. Thank you, everybody.
Thank you very much.
Thank you.